Good evening. Engineer Suraj Singh from India, Bharat, regarding this video entitled Mathematical Formula Demonstration, Equations, Geometry, Shapes, Combination of Shapes, Various Combinations, Letters, Drawings, etc. I have talked to you many times. I shared with you many files, Excel files regarding various composition of formulas of various shapes. I am just giving you certain drawing on which I directly compose these shapes so that you know. Maybe it's not very clear from spreadsheet files because I copy from here onto spreadsheets, or you can say Excel files, because it's not allowed to draw on Excel like this. So I'm just sharing with you these files, few files. This one file, that is geometry. Other one is this file, and this is this file. These three, and I'll share more with you once these are finished, because I cannot open all files on this video due to memory issue, and there are certain restrictions by ZWCAD, because this is free software on which only 1000 objects are allowed in one sheet. So before, now this is that one, it is, you can say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, and here is, you can say S, T, U, V, W, X, Y, Z. Well, it's very easy to say it can be drawn, it can be done. But my purpose was not that. Yes, it can be drawn, it can be worked out, it can be calculated by direct calculations. But purpose is not that. Purpose is I want to draw once and use it number of times with different dimensions. That was my reason. That's my requirement or your requirement. Means every time I cannot draw again and again with different dimensions and then work out or use it. Drawing is different. I'm not drawing with direct dimensions. I am taking certain variables in form of A or base, you can say A or unit of that shape. And that is my criteria to evolve certain functioning, that you can change that form, change that base and work out its area, its perimeter or circumference, and also 3D volume or 3D surface area. That's sole purpose of this. I understand maybe you people do not fully agree sometimes, but I also put here, you can say, certain list on text of this video. That list gives past URLs regarding formula demonstration that we carried out, and you know it very well. So now let's start with this. For example, I say this is my A. I use this A, this is simple form. This another form also I use, which I'll show you, and that's this one here. You can say it was there, maybe in some other file, I'm not sure. I opened that file too after some time. Yeah, it's there. Yeah, it's there. A is there. It's given somewhere. Let me see. All right, now I'll open another file. Let me see this. So this is A. I put this base here, this base, and in relation to this base, I fix all dimensions, and I don't change it. So there's a dimension, but I'm not using that directly. For example, this is 80 and this is 50, but I'm using it 8A and 5A. And example is here 3A, this is 3A, this is 3A. Similarly, this is A and this is here 3A and 3A. And if you want to see exact dimensions, it's not a problem. You can see it here, and we can say, okay, this is, for example, this is 30, and this is 30. Okay, and this is 80, this is 80 like this, and we can say this is 10. That's not a problem. Problem is not that. It's just there. I'll take it off. No need of this because I want to use variable a, so I proportion it like that. All dimensions, and I fix area 1, area 2, area 3, area 4, so that I can use different type of, you can say proportional mathematics, x square plus y, we say like that. So a plus 8a, like this means we say that's what here, and same thing we apply to other letter as b. Shape is square 1 in this case, and here it is c, here it is d, likewise. And because this is d and there is a tapering here, there is a trapezium type situation here, this we can directly calculate. In these cases you can directly calculate this rectangle and this rectangle and this rectangle and this rectangle. We can use formula directly here. There's no problem because we take this, for example, 8a into a, and you can say 3a into a or 3a into a, and like that you can say there's no problem at all, like a plus 8, a plus 5, like this in parameter form. You can do that. Similarly here we do this, means we have dimensions and we can go on finding in a form 5a into a, so 5a square you can say, 3.53 into 3.5 square you can say, 6 you can say here 6a, for example, 6a into a 6a square, or inside there is 4 into 4, whatever it is. So this plus this plus this plus this plus this plus this, like this you can find parameter, this plus this plus this, all we can do. No problem where there's simple square or rectangular figure. It's no difficult for proportionalized as well, where there is something non non-rectangular, where there's a slope or tapering or something. So we can say, you can say radius, not radius, for example, I say aligned. If I take this, just a minute, if I take dimensions aligned, we may say here, this is, for example, here is something else. Now this part and this line and this line are different now. So we have to be very, very careful now. Means this is left 50, this is not here. So we have to use this something here so that we can find that. For example, we can use here, you can say, I just what I did, I lined in there, put line directly so that this area 3 is separate, this is 5. Now this corner, which is tapered one, I draw like this and converted it to a trapezium. This is a right triangle and this is a right triangle and this is trapezium. So we can find that we have this A here, we have angle here, we can measure on AutoCAD, that's not a big deal. And this triangle, both right angle triangles. Similar this right angle triangle, we have rectangle here. This we can find out from our angle, or to a 90 degree, 90, and we can know what's there. And we can find out this angle. That's not a big deal. We can find this angle, and that's why we can move like this. Means we cannot find everything here. Similarly, where this situation doesn't arise, now I say, for example, because I'm removing, there's a memory issue, so I am just removing all the dimensions. No need as such, and I would say same way. I've taken A direct, there's no problem, all rectangles are there, so all A, transformation of dimensions to A. Whatever I took, I divide by that 10, because I'm keeping A 10, you may keep it 5, you may keep it 20, you may keep it 50, you may keep it 1, it's up to you. Then we have to F, E and F, you can say E and F are A, and similar application has been extended to that one, E and FA. Okay, now F, so you understand what I mean. And G also, this is rectangular G, not curved one. I have the curved one also, but I divide the same thing. This means 50, it is of course as shown, but it's 5A, you can say 8A, 5A, like this, dimensions are there, area rotations are there, and same way H. So it's A means, and of course I can say 1, 2, 3, and this dimension are very clear, very clear here. You can see J and K for yourself, and no problem in that. Just you can watch this time. I'll blow it up so that you can find how was it drawn, because you yourself see how it's drawn. There's no problem in that. Okay. I hope you have understood this. Okay, yes, I gave you. You can understand that, and it's not a big deal. You can see why this shape has been taken like this. I have dimensioned it properly according to its size and divided 1, 2, then 3 here, this triangle, and you can see area number here 4, this triangle, and 5 here. 1, 2, 3, this triangle, this 3 and 4 and 5 here. And according to dimension here. Now why did I mark this dimension only for reference, for information? Direct use is not there, I took, as I written A here, means this 10 is A, so everything is converted into A, and we have taken this accordingly, which I have shown you on Excel. This L, which is of course 1 and 2, and that is, dimensioned, not directly given, but it's same thing, same procedure, and there is no change in that. So we say, then we go to, you can say M. I've taken rectangular M. You may call it rectangular M and rectangular M, though these are different also on another mode. So this 1, 2, 3, 4 areas, dimension 9A and 8A. So example, same thing, 8A into A, 8A square, and here 7A into A, 7A square. We use that way, and parameters directly added. Then you can say N is also same this way, means similar pattern, and of course O is there. So this is a line because it's open, so O is very simple, same way 8A, 5A, and P, and you can say same way Q, and it is R, normal one. So we have now, before starting curved ones, so we can say A, B, C, D, we have gone through all this, and you see other file, that is S to Z. S to Z, we can say that this is S, for example. This is rectangular S. This is not curved one, this is rectangular one, as we are talking of that, and it means we have to understand, because easy to draw, first of all, easy to work out, but actually this is geometrical S, this is not real S, and with the same type of dimensions as are given here, no direct dimensions, all indirect algebraical dimensions, and you can say here T with similar pattern, and U also similar pattern, and V, of course, I have taken direct V. There's no other way to take V in this case. So, of course, we have to take V that way. And just like we did in case of K, you can say here, it's V. Required dimension here, as it should be, in dimension wise. And, here, area 1, which is trapezium. You can see this. This is trapezium. These dimensions are there. All dimensions are this, external, internal, both. These dimensions are there, and base is there, which is 10 here, and this 10 and this 10, accordingly this is 10 actually, this is 10, and we have taken dimensions according, this is A, and this is A, and this is A, this triangle area, and this rectangle. So there are 3 areas, 1, 2, and 3. So you can say this is the isosceles triangle here at area 2, and 1 and 3 are there. And this is very, very important for calculation purpose. These dimensions are for information. There is no meaning of these dimensions. Automatically, these dimensions evolve in calculations when you do proportioning, when you do proportional calculations. These dimensions will automatically evolve on sheet of Excel or spreadsheet. No need to worry about that, because proportioning it is. Then you can say W here, rectangular W. Or rectangular here, nothing inclined like that, that will be done. And of course here, X. So this is not actually that type of X, but just for some decoration purpose, for purpose of geometry. There's no circle, no curve here. Same way it's Y, and 1, 2, 3, 4. Z is actually inclined. And this is Z, which there's no way to draw Z like this. You cannot draw this like 2. That doesn't work in that way. So it is actually like that, and just like we write and 1, 2, 3, 4 areas, 5 areas, and this dimensioning here done like that, and so it is that one. I think you got my point, and we will see other one now. I'll see this first of all as to this is geometry, MN OP engineering, and let me see if I can open some other file which is there, and let me see if I can reach there somewhere. So all file if I open, the video will crash. That's a problem. So let me see if I can say AK. Let me try AK if I can. Let me try AK. No, this is back file. I'm sorry. Now this is not there. So M plus SZ1. Let us say. Let me say some file which may not work here. Geometry 1 here. Let me say M plus AR1. Let's say AR1 file. Let us say AR1. So already AR1 is there. All right. Let's open from here itself. If I can do that. Geometry 1, 2, 3, 4, 5. AR1. Okay, it's already there. Let us see serial number PQR. Let us say this file. I use it randomly. Yes. So let's start. R. Okay, let me close it. All right. So I want to show you A actually, because A, yeah, it's there. So A here. And we'll go to A. And AAC, BCDG. And then there's an A, I'm going to pick R, geometry A. It's some file, by chance I don't remember where it was. So, geometry, I'll say SZ, let us see SZ. So many files are there actually, I forget something. It's difficult to retry that, but no problem, we will manage, because I have to tell everything in details. This is R1, then A to R1, 5, A to R1, let us see if it works. Well, unfortunately, I'm not able to gather one. It's there, but is that not one? Well, I'll go to this one then. Let's see B now, first of all. Let's see B, how it works. You see that one, this B. Can you read it? I have drawn this B. This is B. Dimensioning is there, or forget this dimension. I will to consider 8A and 6A or 5A, wherever it is. And this is semicircle here, and this other semicircle here. Right? So we require this rectangle, and this rectangle, and this area here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 are rectangular areas, and 5 and 6 are circular areas, semicircular areas. So we have to consider this in our case. Means, we have, I've shown R values, radius values of these, inner one, external one, and middle one. This is there. And we have to see how it runs away. We have full semicircles here. There's no conflict in that. There's no intersection on semicircles because there's a difference in these dimensions. This is a little inwards, this is outwards. So these three curves will be used fully, and these three curves will be used fully for purpose of this. So same it is, some little difference in drawing is there, but it's 12.5, 17.5. This is this one. This is a factual one. we can say, oh, okay, no problem, we can forget this. So this is 25, 17.5 is 25, 28.34, according to AutoCAD dimensioning or measurement. We can rely upon that. In fact, it should be 27.5, right? Because 27 and 12, that's 39, so it's 40 actually. If you take, as I say, let me say measure in 3i, what's dimension here? We can say this is, like this up to here. We can say, okay, this is horizontally how much, 50 it is. Similarly, how much is horizontally? Is if it is a distance measure from here to extreme point of this. If you measure it there, we find, here, this one, this is 60. So we have this one. Now, this we drew and we use this formula. Same way, 1, 2, 3, 4 are rectangles, depending on the size you are taking, and also this B, which is, this length, and this length. We use this length and this length here, and we go ahead. This is what here you can say C is very simple. In fact, we are dimensioning, and we did A here, and this is semicircle, very simple. And this is 10 here, then semicircle starts here. So we just use that and move forward with R40, R35, and R30. That's not a big issue. Then same thing we do for D. That's means rectangle portion comes to semi quarter of the circle, then rectangle, then quarter of the circle, and we use it accordingly. And G, because the EF is there, of course. G which was previously, this previously is rectangular, and this has been curved to arcade curve, So it's like this, same type of dimensioning is there, which we have used here before. Now, let's say how to do it, how not to do it. It's now a point here. Just to understand means what it should be or should not be. That's only point. You have to understand. By chance there's an error. Oh, no problem. I'll keep on file. So this is G, and we can say that I think I lost some file, right? Maybe I lost some file. No problem. Okay, so we can, area 1 is rectangular, area 2 is curved one, area 3 is rectangle, area 4 is curved one, and then this is twin rectangle one. This goes like this, area 5. So we can directly calculate like this, and here we can use this 20, 25, and 15R. And you can say, if for example I'm using 25R, I will say 2.5A. As 1.5A and 2A, I use the formula to find area of curve length, whatever. So this is G. So there is no other except K we have already discussed, and I can say that it should work properly. Now go to I can say SU and X. Before that, if you can want to see SU and X. SU and X, it is, SU and SUX. Well, before that should be, I think, M plus it is. Okay, M and O P Q R. M and O. You see M. We are not using now this way. The shape not rectangular. It's a real shape which we are M. For example, we use like this, and N here we use like this. M and N. So I compose in a way that M and N can be used together. So we can say A here and same 8 proportion. I am using 8. If you want, you can change it, but you have to apply that everywhere. Remember, if I'm using A, means if it, then you have to change in formula, which I have taken all formula on Excel according to these diagrams, according to these sketches. Means if you want to use those, you have to follow these sketches. But A is variable. In 8 also A is variable. These dimensions automatically would change if you don't use AS10. If you say 5, certainly this diagram will invisibly change. You may not see diagram, but you will see results of quantity same. That's where it is. So this is like that, I link these two like this, and we got M here. In this 1, 2, 3, 4, 5. 5 areas are given. This is trapezium area. This is another trapezium. This is square area. This is another trapezium, and this is trapezium. So 1, 2, 3, 4 trapeziums in this M. One is square. Similarly, if you go to this N, this is this one, this N, this one. It is, this also forms one trapezium here. This also forms one trapezium here. And this also forms one trapezium here. So we have used trapezium as unit, but here they were and we calculate them accordingly. I'll show you Excel file later on because I'm using now AutoCAD on screen share. I can't change format of this myself. If I change it, video will stop. So I'm just showing you drawings in this case, and later I'll show you Excel sheet. So this is 1, 2, and 3 trapezium here, and this is trapezium here, and this is, you can say, rectangle here. One rectangle, area 1, 2, 3, one rectangle and 2 trapeziums. This is area N. O, we know it's simple. 2 semicircles here and rectangles 2, and we can just dimension 15, 20, 25, and we can calculate 1, 2, 3, 4. 1 and 3 are rectangles, 2 and 4 are semicircles. And dimensioning is in proportion. There's nothing wrong with that. And now P, we can say P here. Also, this portion inside is open and this portion is closed here. And this rectangle you form, this is another portion of rectangle. So this rectangle and this rectangle, whole, and this rectangle, and this is full semicircle, half of a circle. And we have radii with us. We use those radii, and we got this. So we can very conveniently use. There is no confusion in this. Only curve, one curve. And here cube. It's a little complicated. It is actually. It looks like that. We drew like this. This is cube here. This is 2. This is a figure giving here 1 and 3. This is 2 areas which are rectangular. This area is semicircular. This area is semicircular. And here this is neck. Whatever call it, peg of a or Q, or whatever you can say. You may say a kind of a reel, whatever name you give. I little mind about that. So it is like this with similar type of, but this is measured separately, and this point is fixed at the end of this curve, semicircular curve. So we have here, we have other the trapezium type figure here, or you can take this rectangle, or you can find it's a rectangle. I'm sorry, trapezium here. This angle is 45 in this case. This angle, sorry, this is right angle, and we can find all this with this one. So this and this and this can be used as trapezium. So there are 2 rectangles, 2 semicircles, and 1 trapezium. Now comes a very, very complicated arrangement of R. It's complicated in different way. You can know P is like P. If you see P here, it's like almost P, and then it's extension added here, this arm, this neck, or this, you can say whatever you call it, with this dimensions, very complicated dimension here. These are not complicated, curve length, and this all okay, fine, and we have dimension here with A as this one, and this is because here's a curve, circle part, this portion is a curve. This is a very complicated portion, means just to find its area. We have straight line here, we have straight line here, straight line here, but this line is not straight. So we cannot even call this a trapezium. We cannot call it neither trapezium, nor square, nor rectangular, and not even a curve. So this portion is very difficult to understand, because there's a triangle also here. This triangle we can separate from that, but this is a straight line, that's okay. These three straight lines, this is not straight. This is very difficult to understand. If I use it as curve length, whole curve comes in. I can't sect here, and then I don't know, means this portion is also in parameter, I'm sorry, circumference. This circumference is up to here, but I have to calculate this length, this length, and this length, this length, and this length for purpose of external circumference. So this portion cannot come in that because this is inside. So what happens, this portion is really difficult. So what I did, I partitioned this portion. I divided this portion of A, this portion of A, that is A here, into 5 parts. 5 parts there. This is dimensional, don't be confused about that. This is one line, okay? This is one line. This is another line. This is another line. This is another line, and this is another line, and this is another line. You can say 1, 2, 3, 4, 5, 6. So when this is division of 5 parts, there are 6 lines, and these are measurements I am showing. These measurements are to every line. This is 1 measurement, 2, 3, 4, 5. I did it because I just wanted to constitute a curve here using lines, and it worked very well. I partitioned it 2 meters, this each one 2 meters, because this is 10 meters say. So if you want to take 10, you can take 1 meter each. It's up to you. But I didn't want to take that much, so I just took 2 meters. Fine. There are 5 divisions, and these divisions we give you, how many you give you. You can say this give you 5 trapeziums here. You got my point. What I'm saying is there are 5 trapeziums where I divide this curve into 5 straights. 1, 2, 3, 4, 5. So you can then state is, in this case is 2 meters length, 2 meters length, 2 meters length, 2 meters length, and 2 meters length. So I can say that I can use this as trapezium 1, trapezium 2, trapezium 3, trapezium 4, 5th, like that. That's only. And then there's a triangle here, that's not a problem. Then this length, when I get this length, because I have to deduct from this arc in external circumference this length of semicircle. This arc length I have to deduct from that arc length this one. That's an important point. How to do that? That's another point. So this area has 180 degrees from here to here. You know it very well. Whole is 360, and this is 180 degrees. From this point to this point, you see 24 degrees is formed. So 24 degrees over 180 degrees part I have taken for length of this one. Length of pi r is half circumference, pi d is full. So pi r is half. So this is r here, this is r here, this is r, and pi r, if take pi r, we get this value. So from this value, if I take out 24 over 180%, 24 degree over 180%, we get this value. Means if we can find this value, there's no problem. That's what I use this one for. And I'm just trying to tell you means how far could I go to constitute formula on spreadsheet. That's one part of it. And let's see, SU, I think I have not told you. Let's start with, I'll go back again to file where A is. I think there's some error either in this. By error I removed that, but let us see, means I can't confirm it. X here, X, SU. Let's see S. What is S? You can see this S here. So this is very exact. It is, means like this. 1, 2, 3, 4. These are rectangular. This is semicircle, and this is semicircle, right? This is radius is middle, external, middle, internal is given here, and this is dimensions here. So we have A here. So we have no problem measuring this, and we have to work out semicircular here for this. This is what is S about. And also if you see U, it's similar except there's one semicircle here, two rectangles as usual, 15, 20, 25, and we can say X here. X little, it's tactical in a way that, if you see actually, if you see especially inside is, it's actually 9A and this way is 8A. So we got these area 1. There are actually, if you see here, if you closely look at this, you will find, from here to here and from here to here, there are such different type of geometry. So why did I divided this part of one? I am calling it wing, one wing, second wing, third wing, fourth wing. So in this I converted this one wing into two parts, part 1 and part 2. This is a trapezium now, you can see this is a trapezium and this is also a trapezium. So there are two trapeziums in one wing and there are total 4 wings, so there are 8 trapeziums, and in middle there is different shape, and this is called rhombus. X is rhombus now inside. So there is one rhombus and 4 wings, and then there are one rhombus and 8 trapeziums. This is what beauty lies in. Angle is given, 83, so 7 degrees vertical angle for trapezium. It is 7 degrees here. If you take this one here, you will find 7 degrees. Axon is 83, so 7 you will find this one, and this because this is twisted, so it is 10 point something. This way we form this one and we use this, which is not very difficult. In fact, I should say, let me go to what I say exactly. Sorry. I'm sorry, cold. I'm very sorry, extremely sorry. Now, I should say that I was thinking of something. I'll show you something else before jumping. I'll show you geometry 5 what it says. Let me see geometry 5 what geometry 5 says. This is an old file actually. This old file, and this gives you have seen all this. This is Shakti David, and this is combination of swastika with this, and here separate one, and this is also David inside swastika, and this is combination of this I call it swastika inside this David and Shakti. This is a drawing of that one, and then a star is also there. I'll show you later on, but I'm just referring to this also motif, octa motif I discussed before you. So I'll close this file because this file is not going to be. I'll show you later, but let me. I was finished, yes. So let us go to find something else here. Geometry 5. What was geometry 4? Geometry 4 is also almost similar. So yeah, many times I close this also because just it was expansion of that one. I put swastika inside this David Mark Shakti, and I'll put that back, out from this, and let's say no to saving, and then we go to 4. I'm sorry, 3. What is 3? Let us see what is 3. This is another form of that. So let it also go. I don't need this 3, and let us see if I can use 2. Again, same thing is coming in. So many files are there. So that's since swastika. To cruciform around this. So I'll put it off, and so I'll say let's go here and see geometry 1. Geometry 1 start. This is actually basic which we used in this case. You can see how many sketches are there, how many diagrams are there. It starts from rectangle, square. You can say square goes to square, and then it goes to even rhombus, and you can say that it goes to square and right angle triangle and parallelogram as well. Parallelogram and all takes in, as well as right triangle, and this is isosceles triangle, circle, triangles, like different types of triangles here. You can see different types of triangles, and here hypotenuse Newton, and this is a combination of various triangles, isosceles triangle, right angle triangle, this right angle triangle around and circle, and there's a triangle inside, and you can say triangle and square, and you can say triangle and parallelogram. means different type of work. And then you also can see that this is, different type of trapezium. One is symmetrical and one non-symmetrical. Two types are there. So I think something is with, this is, pentagon, and this is hexagon, and this is, you can say, septagon, heptagon, and this is octagon. So it means this is a 5-sided, this is 6-sided, this is a 7-sided, 8-sided, and this is, you can say, 10-sided here, 9-sided, I'm sorry, 9-organ, this is non-organ, and this is your, you can say, this is 10, 3 and 3, 6 and 4, 10, decagon, and here you may say combination of these isosceles triangles and pentagon here and pentagon here and pentagon here. This is that type of drawing, and the geometry 1. So I mean, I might have seen that, so geometry 1. So I'll say, means how it goes. So I say no, saving, and I'll say geometry 1, and what the geometry says. Let me see what this geometry says. Geometry also says something, well, which is same thing. I don't know, maybe a change side, I'll take it off. I'm just trying to find somewhere else now. I have to see geometry AK, what's AK, AR. This is AR, O, was the back file, ARO. This is file which is, I think I got what I was searching for. Yeah, that is that one. So it's lucky I got it. A, which I was looking for. I missed the file. It's in, and you can see this in this file, the geometry A. Geometry A. So you can say, if I put some other files, so you can see this dimension is very important for A, which I'm telling you, this is A here. I just put down here at 15 about this length of two arms of A, and this is A, and you can say this is A. Distribution of dimensions like that. So this area, it goes like this, and so there are so many areas in this area A. There's a triangle here. I converted one area A to triangle, 3 to 1, rectangle, and then here 4. Well, maybe it's not area, it's combination, it's complete here. Up to here, this is one trapezium here, this is a triangle here, this is another trapezium here, and this is, area 4 is here, which is a trapezium. Area 5 again, same thing as, it's like the trapezium, and this is area 5 and area 6 here is area 6, which is opposite like this, and there is 7. So we can say these areas are mentioned here. I mean, it was not easy to decide, but all the engineering is done in this case, and you know that. So I was looking actually for this file because there's some problem. I could not save file properly due to my problem of memory in this. So why say now, if you go, you know very well that this is A, another one, and that is this one, and this one is this is that, and then here is this one, which is P R bar, and also that is geometry, and now geometry Z, and this as well. So I've given you various shapes in this stock, which are really very interesting, because these are units, fundamental units, you can say. Fundamental units means you just devise one, and that can be used a number of times if you are dealing in letters writing, or you can say it doesn't matter what dimension I'm taking. Means you take A and value, even if you can take A 1 millimeter, 2 millimeter, it works. You take 1 centimeter, you take half meter, it's up to your choice. Means result would be proportion, in proportion. You will not get drawing, but result will be in proportion. That's where it works in. So A to Z, I've not taken letters yet. I mean to say, previously I did this work on long back, but I did not. I work out these areas manually. Now it's different case. I'm doing work on. Now I close let me close this file. You have seen this, as you have seen, you have seen, all you have seen. So I put it off, and this is geometry 1. So I put up this file. Yes, and you may see that. Also, because I don't want to open all files to cause a problem, I'm going to open. I also close this file. This is geometry N. Before that, if I can open something else in your interest, and that is plant shapes, maybe the scraps are in, and that's my worry, I don't know. Let me see this on how many files are open. Geometry M. Let me close this Geometry M as well. I have seen this file. I close Geometry M as well. So let Geometry M also go because I have to open some other file here. That's that's here and say you see. Long back I did this manually, it is not required manually now. It's calculations, ABCD up to that, you can say. This actually was title was residential building shapes, and all these are manually written here, even swastika and crucifix over there. And this is, for example, some carport here, some medical center here, some market here, some school here, substation here, community center here, police station, pool, and you can say like that. The dimensions doesn't matter, dimensions don't matter, but all this, I did not complete it. I did not complete curved ones. So this is for purpose of building, but not as I close it now, because this purpose is not current one, so I put it off, and I can say that what plain distance welding, and I can say I am only able to open these files, and I can see that which one's that vertical file. File, yeah, is that again? I open that because same diagram which I showed to you there. I expanded that one. This was not done before. This was also not. I have another page that gives many different ones. So this was not done before, so it didn't. And you can see this diagram. Two diagrams are very complicated here. One is this, This is not. This is star actually. Star, which is star means American symbol. On that star is there five corners. Five corners here. Not you can see yourself just this one, so that they put just. So star, you must have seen, it's not Shakti sign, it's not David sign, it's a star sign having five corners. It's having isosceles triangles, and all these isosceles triangles here, and common center here, y projection, and this is that one. So this is a kind of pentagon here. That's what it says. And here is combination of, this is octa. I call it 8 means octa. 1, 2, 3, 1, 2, 3, and this 6. 3 and 3, 6, 2 and 8. So, and this kind of square here, if you draw, and you draw a square here, and put that angle of 45, or this is one, this is the other one, means if you rotate at 45, you get this shape. You might have seen this shape on somewhere in Arab world, put on their walls a motif like this, and this is a kind of area, circular area. This is another kind, and you can see this kind of you can do. And say this is a combination of various shapes. Circle is there, radii means rectangles are there, and this square is there, isosceles triangles are there, and also this right angle triangles are there. So different type of compositions in this. You can fabricate such geometry. There's no problem on that. And of course this is, as I showed you before. So this was all done very accurately, and then converted to A, etc., etc. So, for example, I took dimension in this case. Let us see what dimension it was. D, LI, and this is, it was You can say 90 it is, and I say I'm not leaving dimension there because memory issue is there. 90 is there, and here it is. Here it is, 100, and it is otherwise dimension is not in that. In other one I showed to you 80, so it is 90. We can make it 80 also, but everything will change. This 10 will be affected. Actually, A will be affected. Let us see how can we do if I say okay, I want to make it 80. So we have to use a scale somewhere, and we will find that. Because I cannot use the scale directly for this area, and you can say that this is inside that is there. That's why here in this. I'll close this file also. That is, I close this file also. I'll say, and so I have no geometry A to R on this one. So you can say that A to Z, A to Z, we have A. I use this means above this. For example, there's A. J is actually here. A has gone there with A, and it means when I discuss with you this on Excel file, it will be easy for you to understand that. Basics first, maybe you cannot see those letters very clearly on Excel because of a copy, and the same size doesn't reach there. You have to blow up that, only then you can see that. I think you are getting me very well with this because you can directly find area here, but that is for every time you have to find. But when you use this product, use scaling, I mean to say proportioning, you will find different approach, different approach, and that's where art lies in and concept lies in. Formula, we have to use formula only then. For example, I found difficulty in working out this R, and Q was if I changed Q direction now this way, R this way also, because I want some reality, and also that's very important point. We can say, for example, R is not here, in that case R is gone again. I can't open file, so it's really interesting to know. Means I'll show you B again here. You can see B again here, B, and what we say here is this B, geometry of B, and also C, and you may say D, like that. Of course, I shall review all this one time. If there is an error, I may correct. But I don't think there should be some error. There may not be much error in these files. I don't know why it's not opening. Sometimes it's the error. There's command 3. It should be command 3 actually. So it opens now. Okay. So let me say I open this again, and you see this MNOPQR, which I was talking about. Particularly these two, Q and R, are very, very difficult originally, because we changed this one here, and it's not ordinary one. Same way I changed it one here. It's not ordinary one. You can see. For sometimes it's of something very small element, a member of, if you have to face difficulty in understanding. So there's so many other. I do also compose letters like 1, 2, 3, 4, 5, etc. And that's also very important point. It's also very important from this issue point, and that's very important. And for example, plan shapes, etc. is taken, and geometry, and you can say, I don't know, means volume E. It's like that, means some drawings. For example, let me see some drawings here. Sorry about drawings. Which drawings are there? I don't know. Which drawings are here? Some drawings now. Some drawings. Oh, these are very big drawings. Maybe it's difficult to open them here because of memory, but there's some technical drawings as well here, and technical drawings here. And for example, let me open some some plan revised one. Let's just the one revised. Maybe I scrap it now. Maybe it's not open. This is very difficult one. Very full memory drawing. It is different one. You can see this very big drawing, and it's not. I can't save it on this. It's a drawing here, and I should close it before my system crashes in. So I close that one. Sometimes you have to be impatient about this. Well, I want to show some very specific, but I will show now. I was going to that specific. Yeah, let us see this rather than this. I'll show you some templates of drawings. Let us see this one. You may see this. This is some kind of very old drawing. This is manhole details, and these are here manhole details, and like that, very big type of manholes. You may not be interested in them. I close them, so no problem. No, my purpose is different there. My purpose was not that. My purpose is about letters and about numbers. You may, it means you can say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, and M, N, and S, T, U, V, W, X, Y, Z. The other drawing, P, Q, R, and this is here. And of course, there's some of the drawing R and Z I showed to you. I hope you got these points interesting to an extent. This is concerned. Well, I tried to show you something which we followed in last talks. I'll have many letters from Excel which I cannot put in here now. Otherwise, I would have done that, but it can't continue like that. So I just wanted to bring to your attention what way I have done this, what my plan was to do this, and you have seen I covered many shapes from a square to letters and all that which can be worked out. I have many more much in my mind, but it takes a lot of time to work on Excel for these types of activities, but it is enthusiastic in that way. One should be, one should have patience. Once you have to do it, just like you have to compose some Word file or some other file once, but later on, editing is not a big issue. That can be edited very well. The same thing applies to drawing file. That is, once you have to work on that, then you have to edit, and it's a kind of means the drawing tells you what you're doing right or wrong, because it happens many times. What you think inside doesn't work, but when you do really, you change, and it happens that way. Really, sometimes what I say, I think you got my point, and got my point well, and you can say this very complicated figures therein, and you understand them. This is just demonstration of my drawing. I cannot compose in your presence. It takes a lot of time, and I just show you like this. And now I think I'm not very strong today. And I think I'll discuss with you these, you can say, spreadsheet files, how to work out on all these. Maybe tomorrow, maybe some other time. So already I want to close it now, because I have many things to show, but sometimes it's difficult to find files immediately, just like I found manhole files, and there's so many other files. Actually, I was looking after for one file, it did not find, And what's a structure? What structure is that? Oh, this is useless, It's my photo, and I don't know such a my photo is old one, and there's some plan. I'm not interested in the show that one. And building, what building is that? No, there's nothing not to show. It is in 3D. House isometric, leave it aside. So well, then you can say I'll go back to E drawings, and I'll go back to then E and see which drawing is worth to be, good. No, it's not that one. I'm sorry, then you can say what's the drawings? It is drawings, it's same one, right now this one. So I'll go to it's some drawing further, but trying something else. Let's say what's that? House plant device. House plants is ours. It's numbers designs. This is another one. This is old drawings. What is old drawings? What old drawings? Detailed plans for the house plan. Okay, it means this is that one. This is the framing. This is structural one. This is this one. So okay, leave it now. Okay, guys. Old drawings. Now, actually, I forgot which directory is that. This happens. It happens all the time. People forget, and I am also one of those. So I'll close this now anyway. And I'll just close this video. And I hope you like it. You may give your feedback if you wish. It's my pleasure to just provide you information about how this work was done. This work was done on actual drawing, and then I copied it out to Excel sheet by different type of method. Not exactly what method is done, but different type. That's what we done. So I hope you like it. I wait for my spreadsheet presentation, which maybe I do tomorrow some other time. Therefore, I would say to all of you, whoever may like to view, though I have not seen any joiner today, no problem, it's up to you. And if you join, your wish. And I think I close it now.